Okay, so I wanted to finish up 6.3 today. I apologize again for um, being gone. Anna got the stuff that Eliza had, of course, last week. Um, and then everyone's sick at my husband's work, so he had to be at work. So I apologize, you guys, because I know this is like 2 weeks in a row because of the snow day that we didn't get together. But I think we can do this, this will be fun. We'll do a little video here. You might hear my daughter pop out of her room every now and then, but I told her to try and be quiet. So I want to finish up 6.3. So remember at the end of class on Monday, we talked about, well, what if we have, so let me kind of draw what we have going on here. This was at the end of class, we kind of talked about, well, what if we have an angle? Ooh, let's do some pretty colors here. Make this oops, that's not what I want to do. Okay, so here's my axis, and remember an angle has a terminal side that we are going to put on, and it doesn't really matter where this angle goes, but the terminal side is going to be along the x-axis, of course, and then this is the terminal side, the initial side is along the x-axis, and then we have some sort of theta right here, right, representing this angle. And what we talked about at the end of class, and I'm going to undo that, I don't like that arrow, at the end of class is, if I take any point here, let's get crazy and call it P. It has an X and a Y coordinate, okay? And I know that X and Y coordinate, what I can do is I can draw this is a pretty cool little application that I found to do this lecture. I can draw a dotted line down here, and what I have found then is that I can get this right angle right here. Whoops. I'm kind of also still learning it a little bit because I'm not in my office where I usually record these. And this distance is y and this distance is x. And so the important part about all of this, whoops, sorry about that, is that we found then that if I look at the cosine of theta here, or the sine or whatever, what is cosine of theta now in terms of all of this? Well, I have to do something about my hypotenuse here, and we'll call that hypotenuse r. And so what we've found then, or a new way that we are going to define cosine, is x over r. So we had opposite over, or excuse me, for cosine we had adjacent over hypotenuse. And based on how I've written this triangle here now, I just will take the x coordinate of a point I know that the terminal side goes through, and I'm going to divide it by the length or the distance between that point and the origin. Okay, so cosine then is x over r. What would sine give me? Sine, if you look at this, well, it'd be opposite over adjacent is y over r, and then tangent, of course, is going to be y over x. And the interesting thing about this is now, with this definition, given just x and y values, and r, which r is just the distance any point on my terminal side is from the origin, we can actually find now, I know you're excited, I'm excited too, we can find cosine, sine, and tangent of any angle. So remember, we looked at a bunch of different angles. Stop it. So I don't know, like maybe we have an angle that goes, orange, like Bronco colors, whoops. Maybe we have an angle, that goes around here. So if this is my theta, okay, so maybe we have another angle here, and I have some point on this theta, so P of xy, right? And r is the distance from the origin to that point. Again, these new definitions, right, are going to be, these new definitions are going to define cosine, sine, and tangent of this angle, this orange angle here, theta. Really quick, just a fast reminder. I know you guys already know this, but as we're going to start talking about the quadrants, remember this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4, because now what we're going to see is that now when I take cosine and sine, cosine, sine, and tangent of things, I can actually get negatives out now. So before this, we're only going to be positives because I was just dealing with lengths of triangles. But now yeah, we have these triangles, right? I mean, these triangles are there. Okay, so like here's my triangle that I would have if I brought this down. But now look at here. This x right here will be negative and this y will be negative. So when I take x over r, that gives me a negative number because of how this triangle is defined. When I take y over r, it gives me a negative number. Now the one thing we do know is that r is always positive because it's a distance, okay? So I still have that relationship that x squared plus y squared equals r squared from this right triangle that we've created. I hope that makes sense. So let's kind of write this down a little bit more formally. Sorry, there we go. I want to write this down a little bit more formally for your notes, kind of as almost a definition. Okay, go a little bit bigger here. So trig functions, you can put trigonometric if you would like. If you don't like to do the abbreviation, which I kind of would understand, of any angle, okay? So trig functions of any angle. Okay, so we need to kind of set this up. So let's define a point P. Let's let P, which we'll call XY, be a point. On the terminal side, so remember what terminal side means, of theta. And let r be the distance. Oops. Sorry, my handwriting is a little bit shaky on this. It's new. I haven't used this program yet, but be the distance from P to the origin. Another thing I maybe should have said here is, let's let theta be in standard position, but we'll assume. I know what assuming does, but we're going to assume anyway. Okay, so then we define the following. Okay. All right, so here we go. So let's define sine first. So sine of theta then is going to be y over r, which we just saw before. What's cosine of theta going to be? Cosine of theta is going to be x over r. So that's adjacent over hypotenuse. And then tangent of theta is going to be y over x. You're going to need to know these. Okay, so maybe not today, but by next week you're going to need to know that sine is y over r, cosine is x over r, and tangent is y over x. Okay, one little thing about tangent right here, we got to make sure that x is not 0, right? I can't take y divided by 0. So that's kind of an interesting thing. Think about when x is 0. X is 0 when we're on the y-axis. So it's pretty interesting that tangent doesn't actually exist or isn't defined along the y-axis. And then let's look, of course, at the reciprocal functions. So the reciprocal functions, the reciprocal of sine is cosecant. So I'm just going to flip that. So that's y, or r over y, again for y not equal to 0. So again, when is y 0? When we're on the x-axis. So cosecant doesn't exist on the x-axis. Why am I putting sine, people? That's your fault. I don't know why that's your fault since you're not here. I guess I have to blame myself. That's too bad. I don't like to do that. And then what would secant be then? Secant would be r over x as long as x isn't 0. And finally, cotangent here of theta will be x over y, again, where y is not equal to 0. Okay, a couple things I also want to note here is that we know that x squared plus y squared is equal to r squared. Okay, And then the other thing I want to talk about is where are these positive and where are these negative? And then we'll do some examples of finding finding trig functions, given something else. So so keep this in mind. I hope you have these in your notes. Let me try and get another one here. Oh, I think I just messed that up. Okay, so let me slide this in here. And I just need to, again, I apologize for this. I'll get used to this, but hope eventually. Okay, so let's look at, again, I want to show you one thing here, is this idea of what about, there we go. I want to look at what do we know then about the signs, okay? The signs of sine, cosine, and tangent. Now, sine, not S-I-N-E, but S-I-G-N, the sign, positiveness or the negativeness, if those are words, of these guys as we work along. Okay, so here we have quadrant 1, remember? Here, this is quadrant 2. This is quadrant 3, and you guys maybe remember this from when you've had a little bit of trig in the past. But let's talk about what we know about in quadrant 1. So first of all, what do I know about x values in quadrant 1? They are positive, right? So are y values. That's why we're in quadrant 1. In quadrant 2, x values are negative and y values are positive. Quadrant 3, of course, they are both negative. And then in quadrant 4, we have positive values for x and negative values for y. So let's look at what happens here in quadrants 1, 2, 3, and 4. If you notice, well, what is sine? Sine, right, in quadrant 1, oh my goodness, come on. Trying to select orange. I don't know why it's not letting me. My goodness. Sorry, you guys. I know this is probably not lovely to watch. My goodness. There we go. All right, so sine in this case, right? Sine of theta in quadrant 1 is going to be positive because it's y over r. Cosine of theta in quadrant 1 is going to be positive because it's x over r. And tangent in quadrant 1 of theta is going to be positive also because it's y over x. Here's where we get more interesting. In quadrant 2, I'm just going to use s for sine. Sine is positive because it's y over r, but look at cosine. Cosine is negative because it's x over r. Remember, r is always positive. And then for tangent, what do we have? It is negative also because tangent is y over x, and I would have positive divided by a negative. If we look down in quadrant 3, okay, sine is going to be negative because it's y over r. Cosine is going to be negative, and tangent is the only one that's going to be positive because tangent is y divided by x, so a negative divided by a negative is positive. And then if we go to quadrant 4, what is sine? Sine is going to be negative because remember, sine are my y values divided by my r. Cosine is going to be positive in quadrant 4 because my x values are positive. And then tangent is going to be negative. So you may have seen this before. I hope you have, because that'd be very, very exciting for you. Let's grab some pink. Why not? Have you seen All Students Take Calculus? I'm going to just pretend that you're saying yes. So all 3 of these are positive in the first quadrant. All students take calculus. Or you can make up your own acronym for that. I don't remember what other ones I've heard. We could discuss those on Monday. All 3 of those, the original trig functions, are positive in the first quadrant. Sine is the only one, if you notice, positive in the second quadrant. In the third quadrant, tangent's the only one that is positive. And in the fourth quadrant, cosine's the only one that's positive. So the All Students Take Calculus kind of helps you see where you're positive and where it's negative. I mean, another way to think about this is, you know, sine are your y values, right? So sine are y values. Well, if sine are your y values, then you know sine is going to be negative below the x-axis, right? So anywhere below the x-axis, you know sine is going to be negative. So you know sine is positive in 1 and 2. Cosine, on the other hand, I don't know why that's not working again. Cosine, on the other hand, maybe not. I just want a different color. That's all I want. Is that too much to ask? Apparently it is. Cosine, on the other hand, where is it going to be negative? Cosine is going to be negative when x is negative. So if you notice, cosine's positive in 1 and 4, but negative here in 2 and 3. And then tangent is only going to be positive where their signs are the same. So that makes sense that tangent is positive in 1 and 3. Okay, so I hope that makes sense a little bit. Let's try a couple of these. So I want to come back to here, remembering that sine is y over r, cosine is x over r, tangent is y over x. And let me go ahead and clear all of this, and let's do some examples, okay? All right. So for example, that's a little too thick. Okay, find the remaining, okay, 5 trig values of theta Okay, so I have to tell you a couple of things here. Let's just start off kind of easy. If the sine of theta equals 3/5, and this is one way, this is one way we can write this. And theta lies between 90 degrees and 180 degrees, okay? Okay, so theta lies between 90 degrees and 180 degrees. And so why did I tell you that? Well, I told you that because I want you I want you to be able to find what quadrant it's in. Because again, look at sine is positive. So what are the 2 quadrants that sine could possibly be in? It could be in quadrant 1 or quadrant 2. So remember, where are your y values positive? Y is positive in quadrant 1 and quadrant 2. So let's go ahead and sketch this. It's probably going to be one of the easiest ways to do this. And I actually want to move it over just a little bit because I know it's in the second quadrant. Okay. And then just use a different color here. So again, it doesn't have to be perfect. I don't actually know what theta is. Okay, so this is theta right here. But what I do know is I know that y must be 3, right? Or a multiple of 3, and r is 5 or the same multiple as it is of 3, right? So this is a ratio. So, you know, we could have had like 15 over 25 and it would have come down to 3/5. But so that means I can not graph this, but I can label my triangle. So I know, okay, that y is going to be 3/5, so, or 3, excuse me. So what is y? Y is going to be this distance right here. So I know y must be 3. I know that r is 5, okay? And then of course I know that x squared plus 3 squared must equal 5 squared. And the interesting thing here, look at, I get x squared, of course, equals 16. Now when you square root, remember we take a plus or a minus. Normally you'd be like, oh, Sarah, just take the positive. But I actually want to take the negative now because what do I know about x? It must be negative because I am in the second quadrant, right? And so now you can see how you have your triangle. And a lot of times if you build that triangle, that kind of helps you see what to do. And you also know, what is your coordinate here then? -4, 3, right? And now we can use all of our trig values. So we know sine is 3/5. So what will cosine of theta be then? That would be a -4/5, right? What is tangent going to be? Tangent of theta is going to be a -3/4. You could do 3 over -4, that's fine. I just like to put the negative in front. Let's flip sine. So that's cosecant is 5/3. Secant then is going to be a -5/4. And cotangent, of course. We're just going to flip tangent, which is a -4/3. All right, I hope that makes sense. So those are pretty easy, right? It's the same thing that we did, you know, in 6.1 on finding the 6 trig values, except we just put it in a different quadrant. That's it. I want to do one more example. Let's say I know, yeah, let me clear this out. Okay, so one more example. And what I want to give you here is I just want to give you a picture, and then you need to find something here. So find the 6 trig functions of theta. And all I'm going to tell you, I'm not telling you much about theta, I'm just going to give you a picture. Okay, so here's what you know. Here's my x and y, xy plane. Okay, and let's put theta. Let's say theta goes here. Now, what direction did theta go in? Well, it doesn't really matter because my sine, cosine, tangent are going to be the same, but let's make theta go this way. And I have to tell you something about theta, and here's what I'm going to tell you about theta. I'm going to tell you that this point right here, okay, is, let's do 2, -3. Okay, so that's all I've told you. And I want you to find the 6 trig functions of theta based on where theta is at. You don't need to know what theta is. And I've given you a point that lies on the terminal side of theta. So to be able to do this, right, well, what do I need first? I know that to find sine, I need y over r. So I know what y is. That's a -3. Now I need to find r. So that's going to be the first thing that we're going to want to find. And again, a lot of times when I do these, even now after doing this for quite a while, I like to build my triangle here just so I can kind of, you know, see to myself, well, I know this is -3, I know this is 2, and then what would r be? Well, that's 2 squared plus a -3 squared equals r squared. So I get 4 plus 9 equals r squared. And now when I square root this, for sure we want the positive, because remember, r is just your distance from the origin. So I know r then, give myself much room here, this guy right here is going to be the square root of 13, okay? So I should be able to find these now. So, oh my gosh, let me stop doing that. So what is sine then? It's y over r, and in this case it would be a -3 over the square root of 13. Again, for me, that's fine. Leave it like that for my math lab. They're a little more picky. Cosine, that's just going to be 2 over root 13. Tangent of theta, right, is going to be y over x. So that's -3/2. Secant of theta, which one is secant? That's the reciprocal of cosine. So that's root 13 over 2. And cosecant of theta is going to be root 13 negative root 13 over 3. And then my last one, of course, is cotangent of theta, which is going to be a -2/3. And again, I want to point out, right, all students take calculus. What is the only thing that's positive in the fourth quadrant? Cosine. So notice cosine is positive, and when we say just cosine, we mean it's reciprocal also, because when you take a reciprocal, that doesn't change the sign of the function, right? So cosine and secant are going to be my two that are positive in that fourth quadrant. All right, good. I hope that's making sense. Those aren't too bad, I hope. The next thing I want to kind of talk about is this idea of what we call the terminal side on an, if the terminal side of your angle is on, oops, on the axis, okay? So theta is on an axis. What is going to happen if theta is on an axis? So this is very interesting. Well, I get that our ideas of interesting are a little different, but oh well, that's okay. Here's going to be my, again, this is the great thing about mathematics. We have this definition now, right, for sine, cosine, and tangent. So because I have that definition is going to apply for whatever type of angle we have. So let's look at 0 degrees. So 0 degrees. So 0 degrees, right, I can think of as just being this guy right here. Now, what we're going to do when we pick a point on this, I can pick any point on this line, right? Any point on this line I can pick. So I am going to pick the point that is a distance of 1 away from 0. So this point right here would be 0, 1, okay? Or excuse me, 1, 0. And then what do I know this distance is right here? Why am I picking 1? Because it's easy. Right? I could pick 2, 0. I could pick 497, 0. It doesn't matter which one you pick, but it's going to be easy, right? Because 1 is going to be pretty simple. So look at 0 then. If this is 1, and I know this is my x and my y, what would the sine of 0 degrees be? Well, it would be your y value, which is 0, over the length that point is from the origin, and that is just 0. So look at what we have now. We actually can talk about sine, cosine, and tangent of angles that really have nothing to do with triangles, right? I mean, 0 degrees in a triangle doesn't make sense. So sine of 0 is going to be 0. Cosine of 0 is going to be your x value, which is 1, over the length, or your radius there, which is also 1. And then look at tangent. Tangent of 0 degrees is going to just be y over x, 0 over 1, which is 0. Isn't that cool? All right, good. So let's do 90 degrees. So if, again, the idea here is what's going to happen if my theta is on an axis. So again, here's 90 degrees, right? There's 90 degrees. I'm going to take, again, a point that is 1 away, okay, from the origin. And so what are we going to know about 90 degrees here? Okay, what would the sine of 90 degrees be then? Well, I'm going to take, what's my y-coordinate? It's 1 over, what's the distance from the origin? It's 1. So the sine of 90 is 1. Cosine of 90. Cosine of 90, take the x-coordinate, divide it by the length, we get 0. And finally, the tangent of 90 degrees. This one's kind of interesting. We knew that this one was going to be an issue way back when we defined these because we said x can't be 0. And look at what tangent would be, 1 over 0. Ooh, I hate writing that because it's undefined. So you can put undefined, d does not exist, dne, something like that would be, I would accept any of those answers. Good. So again, we're going to need to know these. So we're going to be putting them, of course, in your in our little chart thing. So let's get some pink going here. All right, so 180. Whoops. I have a line tool for a reason. All right, 180. Okay, again, I'm going to put a point at 180. I'm going to put it a distance of 1 away. So this point would be -1 now because we're going in the left, in the negative direction. But again, this distance is 1. So let's look at 180 degrees. Okay, whoops. You get it. I'm leaving some room for 270 here. Sine of 180 then is going to be 0 divided by 1, which is 0. Cosine of 180 degrees is going to be a -1, that's your x-coordinate, divided by r, which is 1. So that's going to be a -1. And then tangent of 180 degrees. Okay, tangent of 180 degrees, y over x, so 0 over -1 is fine. That's just going to be 0. All right, good. And then the last one, 270 degrees. So if I go down here, 270, I'm going to pick a point again that is 1 away from the origin. So this is a distance of 1. So let's look at what happens with 270 degrees. So sine of 270 is going to be -1 because I have your y value is a -1/1. Cosine of 270 is going to be 0/1, which is 0. And then again, tangent here. So tangent of 270 is going to be undefined again because you have x in the denominator and x is 0 at that point. Whew! So we have a sine and cosine of a bunch of angles. I hope this all makes sense. We're gonna need to know these, okay? So when you if you want to do your chart again or something, well, let's just do it. Nope, we want it black. I like to draw on black. Okay. When you do your chart, oh, this is kind of lovely because I have I can draw perfect lines in this program. Unlike on the board. I'm not quite sure how many we're going to need here. We can add some more if we need to. But when we do this, and this is my theta, okay, and I'm going to look at, again, sine, cosine, and tangent. We're going to want to add a couple, oh goodness. Let's move that up a little. Oops. We're going to add a couple of angles, okay? So now I'm going to start at 0 degrees, then 30, then 45, then 60, but then I'm going to keep going. I'm going to go to 90. I'm going to need a couple more. 180, and then 270. And now, why didn't I keep going after 270? Because, well, because we came back around, right? And we're going to be at 0. So then what would my next one be? It would be 360, which is the same as 0, right? So it just starts repeating itself. And so let's look at sine of theta, cosine of theta, tangent of theta. Okay, so remember our trick here that we had before? So remember here I would do 1, 2, 3. Now I'm actually going to start with 0, 1, 2, 3. And then I'm going to actually put a 4 here. And then the 180 and 270 we're going to have to deal with. And then I'm going to go the opposite way here. I'm going to do 4, 3, 2, 1, 0. Okay, so if you remember that. And then I'm going to square root them. Square root and divide everything by 2. Oh goodness, my square roots are a little sad. Divide by 2. So again, this is a trick for filling out your chart now. So again, square root, divide by 2, square root all of these. We'll rewrite them. And divide by 2. That'll get you through 90 degrees, okay? And then let's simplify these a little bit. We don't want to leave them like this. So what is 0 divided by 2? That is just going to be 0, obviously. Square root of 1 is 1. Do not put your answers as the square root of 1 over 2. Square root of 1 is 1. Root 2 over 2 we can leave as root 2 over 2, or you could put 1 over root 2. I would take either 1. Root 3 over 2 I can't really simplify, so I'm just going to do root 3 over 2. And then square root of 4, this is kind of cool, this works. Square root of 4 is 2, and 2 divided by 2 is 1. Isn't that cool? So same thing down here, cosine of 0 we know was 1, right? So I have 2 divided by 2, which is 1. This guy will just leave as square root of 3 over 2. Root 2 over 2, that's fine, or 1 over root 2 again. Square root of 1 is 1, so I get 1/2. And then 0 divided by 2 is 0. So the cosine of 90 degrees is 0. And then how do we find tangent? I just take sine divided by cosine, right? Because those are my x values. So that's why you want sine on top. So I get 0. I get 1 over root 3. I get root 2 over root 2. So that means that what is the tangent of 45? That's 1. We know that. I get root 3 over 1, also known as root 3. Look at this. At 90 degrees, I get 1 over 0. Can't do it. So this guy is undefined. Okay, I hope that makes sense. Let's look at 180 really quick. Sometimes when I do 180, I'll just kind of pick a point right here and I'll do a little sketching on the side and I'll say, okay, so 180, y, right? Sine are my y values. 180 is along the x-axis, so sine must be 0 there. Cosine is -1, and then tangent is sine over cosine, which we'll talk about. That actually is true, which is 0. And then 270, if I'm down here, that would be -1. Along the y-axis, cosine is going to be 0, and then 1 over 0 again is undefined. And then, of course, you can find your reciprocal, right? You find your reciprocal trig functions by just taking all of these and flipping them. Noticing, though, that, like, for instance, if I wanted the cosecant, right, of, let's say, 180 degrees, that's going to be a problem because that would be 1 over the sine of 180 degrees. Right? Which is, what is the sine of 180 degrees? It is 0, so this guy is going to be undefined. So be a little careful about that when you put things into your calculator. Like if you tried to do cosecant of 180, you'll get something that's undefined. Okay, so that was a lot of material. We have one other thing to talk about in this section, and I'm going to leave that for Monday because it's a pretty big idea, this idea of reference angles, okay? Finding the exact values of sine, cosine, and tangent of any angle who is within 30, 45, or 60 degrees away from the x-axis. And I'm already 36 minutes into the lecture here, so I have a feeling I'm kind of losing you, which I understand. So I hope this stuff makes sense. Please get going on the homework. You should be able to do quite a bit of the homework right now with this stuff. And then on Monday, we will finish this all up. We will finish it all up by talking about reference angles and then doing the fun sheet. The fun sheet I will post on Blackboard if you would like to get going on it and if you want to see some examples and stuff. All right, you guys, thanks so much. Sorry again about class today. I hope you have a great weekend, and I'll see you on Monday.